we're going to start working with inequalities for this next section of our learning. And you've seen some of the inequalities before that we're going to work with. For example, you've seen the less than symbol and the greater than symbol from elementary school. And one thing that sixth graders tend to struggle with when we start talking about inequalities in middle school is that they don't have the names of the symbols memorized. In elementary school, you might have been taught a trick such as the alligator eats the larger number, or Pac-Man eats the larger number, something along those lines. And so then what happens is you don't understand what the symbol itself means or how to read those symbols. And that can be complicated for us for the next unit for when you are graphing your inequality symbols. With an inequality, it's different from an equation in that an equation typically gives us one exact answer. But inequalities, on the other hand, tell us a whole list of answers. For example, you might see something like x is greater than 6. So what that means is that x can be any number that's larger than 6. So it could be 12, it could be 52, it could be 1,862,000. Anything that's greater than 6 is a solution for x. Now these two symbols are new for most of you. This first one means that something is less than or equal to, meaning that it could be equal to the number. So if we had that x is less than or equal to 6, what that means is that any number that is less than 6 works as a solution, as well as 6 could be a solution. And if you look at the symbol closely, you'll see it's kind of like they smashed together a less than and a greater than symbol and an equal sign because it has that line underneath. Today our focus is not going to be on solving inequalities. It's simply going to be on how to graph the inequalities on a number line. And when you're graphing inequalities on a number line, something that's very important is what we call the point and whether it's open or closed. If we're using less than or greater than, these two have an open point. So our point will be just like a circle. But when it comes to less than or equal to or greater than or equal to, we're going to use a closed point. So our point will be like a circle that is shaded in. And just a second, when I flip the slide and we go and we look at an inequality statement and we graph it on a number line, we'll talk about why one is open versus one is closed. But one of the things that I do want to talk to you about before we start this unit is that oftentimes kids aren't sure whether their points should be open or closed. And so they try these kind of funky little points where it looks like maybe it's shaded, but it may have a little hole in the middle. And then when I bring it to their attention, they're like, oh no, I meant for it to be closed in. It's really closed. I just didn't shade it all the way. This will not work. So if I can't tell just by looking at your point if it's open or closed, I'm going to have to count it incorrect. I'm not going to spend time trying to decide, well, did they mean to shade it? Did they not? Because you need to be very precise and clear in your mathematical communication. And if someone has to try to debate whether or not it's open or closed, you haven't communicated clearly. So let's look at a statement here. We see that B has to be greater than or equal to -4. So what I always tell kids to do is to first think about your point. Is it going to be open or closed? Well, since it has that equal to, we know that it's going to be a closed point. So that means it's going to be a solid point that's shaded in. And that point is going to be at the -4. So what I'm going to do is I'm going to find my -4 and I'm going to go ahead and I'm going to put my point there first. And I'm shading it in so that it is definitely closed. Okay. Now, B has to be anything that is greater than the -4. Well, we've already put the point, or equal to. We've already put the point there at the -4. So where on the number line are we going to have values that are greater than -4? Are they going to be to the left, or are they going to be to the right? Well, hopefully you remember that as we move to the right on the number line, everything gets larger. So I'm going to shade my number line to the right. I'm just going to kind of, with my finger, my pencil, I'm going to go ahead and shade it. And I'm going to put an arrow point at the end, because that means it goes on and it doesn't end. Anything that is greater than or equal to -4 counts. Now, our point is shaded because it's that equal to. It's shaded because it includes the -4. So everything that is shaded is a possible solution to this inequality, B being greater than or equal to -4. The next thing that we need to do is we need to check our shading. I'm going to pick a number that I have shaded. Here, 2 would be shaded. It's got the shading going down the number line. And I'm going to substitute that in for B just to check and make sure that my shading is correct. So instead of the B, I'm going to substitute in 2 is greater than or equal to -4. And I'm going to ask myself, is that a true statement? Is the number 2 greater than or equal to -4? And yes, it is. So it checks out. You are required to do a check. I should see a check for everything that you do. Every time you shade on a number line, I want to see that check. So let's look at this second problem. -3 is greater than S. So the first thing I'm going to do is think about my point, open or closed. Well, it's not equal to, so it's going to be an open point. I'm going to find where -3 is on my number line. 1, 2, 3. So here's my -3, and I'm going to make my open circle. This is where -3 is. -3 is greater than S. So that means this number where I put that point at is larger than anything that I need to shade. So that means that I'm actually going to shade to the left. And I'm going to put my little arrowhead there because it goes on and on forever. Because -3 is an amount that's greater than S, I know that S is going to be anything that is less than -3. So let me take a number that I shaded in, and here you can see, oh, well, we shaded in that -5. Let's substitute in that -5 for S and check my work. -3 is greater than -5. Now, I want to ask myself, is this a true statement? Is -3 greater than -5? And it is. Because remember, on a number line, as you move to the right, we're getting larger. So if we start at -5 and we move to the right to where that -3 is, we can see that it's clearly larger because it's to the right of it. So my check does work out. Let's look at another couple more. First, I'm going to look at my symbol. It's greater than or equal to, so my point is going to be closed, and it's at -2. So I'm going to find the -2, and I'm going to put my closed point there, making sure it's completely shaded in. A is less than or equal to -2. So I'm going to shade in the direction of anything that would be less than -2. So I'm shading to the left. Now I'm going to substitute a number in that I shaded. And again, I shaded -5. So let me use that as my check. Is -5 less than or equal to -2? Well, yes, it is, because it's further to the left on the number line. So it is absolutely correct. Let's look at number 3. H is greater than -1.5. So first, let's think about our point. Is it going to be open or closed? And we know it's going to be open because it's just equal to. I need to find negative 1.5. So this would be negative 1 right here. This would be negative 2. So then 1.5 is going to be right here in the middle. So I'm going to need a open point in the middle here. And we know that h is greater than that. So I'm going to shade to the right and put my little arrow on here because it goes on and on forever and never stops. I'm going to use the number 3. Let's substitute that in for h. Is 3 greater than negative 1.5? Yes, it is. So I know my shading is correct. Sometimes we are going to look at problems that kind of go the opposite way, and we're going to do those live today. So we will take care of that right after I do my live teach.